Yeah, because it takes at least an hour to get up there. Yeah, maybe longer.
Getting done.
Yeah, on the bus through Golden Gate Bridge. Yeah, that could take a while. Yeah, you drive through the city. Yeah, yeah, so that's annoying. Anyhow, for number three, what I would do is I do Pythagorean theorem to solve for the missing side, right? Hold x, how would you do that? 5 squared plus, sorry, 15 squared plus 8 squared, which should be 289, I think. But remember, you have to square root it. So you should get 17. So x equals 17. So I think all is good there. Okay, now they're asking for the lateral area. So that means you don't do the top and bottom, you just do the sides. Remember, we talked about there's a formula for that. For lateral area, that's the perimeter times the height, right? The perimeter of the base is 8, 15, and 17, right? So you add those up. And the height, of course, is told to you. It's 8 over here. So 8 shows up again. So what's that going to be? That's going to be 40 times 8, which is 320. And remember, put the unit square meters. Now, what if I ask for the total area for number three? One extra step. You take the lateral area, and what do you add it to? The base times 2. Yep. And what's the area of the base? It's a triangle. Yep. So twice times 1/2 times 8 times 15. Those will cancel. That's 120. So you should. 8 times 15. Because when you have a right triangle, the legs automatically act as your base and height for the dimensions of the right triangle. So 440 square meters, and that's good. Yeah. Okay. Now for number four, this is going to be a little more involved. Um, actually, we don't have to worry so much about this, about finding the hexagon, but we could do it a little later. Um, but again, it's going to be the lateral area is going to be the perimeter of the base times the height. Now, this hexagonal prism should be sitting on its hexagonal face, right? Because that's the true base, right? Uh, the other ones are, the rectangles, those are the lateral areas, right? So it's really sitting on. If you guys need that clear, I could even tell you, here's the base. The base is, I'll even make that clear. The base is the hexagonal face, right? So what's the perimeter of the hexagonal face? Good, 24. And what's the height or altitude of the prism? 10, right? And you get 240. That's it. Well, that's just for the lateral area. Because lateral area is just the perimeter of the base times the height here. What you're doing is you're incorporating the base, which we're not ready to do yet. But if I ask you to find the total area for number four, that's the lateral area plus twice the base. So now we actually have to go down that path, right? So if I think about it, if I have a hexagonal base, well, how long are each of these sides of one of these triangles? For yeah, how do I know it's equilateral? How do I know that? How many triangles am I making beside? Yeah, and you go around 360, right? So 60 up top, it's got to be 60 down below. Now that's where you get the root three part, right? Because that's 4 and 4, and that's 4, and that's 2. That's 2 root 3. So if you think about it, the area of your base, what's it going to be? The triangle, right? But how many triangles do you have? 6 times 4 times 4 root 3. That should be 3, 6, 48 root 3. Is that right? Yeah. And you got two of them. So the total area would be 240 plus 96 root 3. Cool. Okay. So that's what you could expect from the quiz. A question kind of like that, right? Um, but instead of lateral area, I might ask for total surface area. Last one, we'll look at number five. Um, Number five. Okay, what's your base here? And by the way, it's total surface area. Is it the rectangular part or the triangular part? Yeah, because you need to have that mirror image on the other side, right? Um, so if I do Pythagorean theorem, that's 25, by the way. So the total area is the lateral area plus twice the base. Well, the lateral area is the perimeter times the height, and the base is a triangle, which is 2 times 1/2 times 15 times 20, right? Which should be 300 when you multiply that out. The perimeter, what's the perimeter going to be here? That's going to be 60, right? 60 times the altitude, which is 25, where that is. That's 1800. So hopefully that makes sense for that one. Okay there. So it's very straightforward. Now, formulas I'm going to give you, um, I am going to give you these formulas. I'm going to tell you, actually, I have it right here. I'll tell you. I will tell you lateral area is this. I'll tell total area is this. So just so we're clear, just so you're not surprised, I'll tell you that. Am I going to tell you the area of a circle? No. Am I going to tell you the area of a triangle? No. Am I going to tell you the area of a hexagon? No. You got to know those. Those you have to know. So
Wait, an area
a circle?
not as prisms, just as 2D shapes.
Yeah, 2D shapes. You should know your 2D shape areas. Yes, you should know that by now. If you do have a formula sheet, like an accommodation, talk to me. I could work with you on that. But otherwise, these are the only three I'm giving you. But the basic shapes you guys should know by now because you've done it so many times. But if you're trying to remember, oh, lateral area plus what, don't worry, I'll give that to you. So, okay, anything else? We good? Cool. All right. So let's move on to the lesson for today. Oh, good. Oh, I should give you three pack. Did I give you three packets? Oh, well, how did I forget you? You got the whole packet. Ah, that's what happened. We're putting these with pairs. Okay, there we go. Yeah, no problem. Okay, so let's move on to the notes for today. We got a lot to cover, a lot of ground. Um, so first thing we want to do, I'm going to try to do this in line with what Mr. Davidson did. So this packet and I did color for you guys too, right before the toner went out. That's why there's a little yellow streak because that happens when actually the yellow toner went out. So I did nice color for you guys, nice and warm. But let's go to all the way to the end. And let's take a look at this part right here. So it's gonna be the last sheet on the notes packet. It looks like this. It says Unit 4, solid and scale factor reminders. Lateral area, total area, volume, linear scale area, scale factor, volume, scale factor. We're not doing that on the quiz, just so you know. That's gonna be our test next week. But we should start having a discussion because this is probably one concept I think is probably the toughest for students. So we want to do work for that. Oh, you got it, Zoe? You're okay? Okay, cool. All right. Okay. So let's is everyone there first? I want to make sure before I move forward. You can't find it? I'll help you out. This should be the last. Oh. Last. Okay. So we're talking about strategy, how to approach these questions, right? So steps for solving problems involving calculation of lateral area, total area, and volume. Read the question carefully, confirm what is being asked. That's just common sense, right? Determine what the base is, because that's going to play a role, right? We need that for lateral area. We need it for volume. We definitely need it for total area. And remember, the bases are two congruent parallel sides. Very important. Write down what's happening, the perimeter, the base, the height, and the radius, right? There's nothing putting these blanks here. That's just for you to mentally tell yourself, oh yeah, I gotta figure out what these are, right? So you need to write down the how, what those are, calculate them, whatever calculations you have to do. Yeah, come on, go ahead.
Are you gonna make like are you gonna make perimeter, base, and height all category letters?
Yes. Yeah, I'll be consistent in that regard. Um, yeah, and then write down the formulas, right? whatever you need, and then make sure you put your units, right? So if we follow that system, we should be okay. So taking a look at this one here, lateral area, surface area, which is total area, and volume. Okay, so first of all, my base is what kind of shape? Yep, that's why let's know what it is, right? Determine what it is. It's a triangle, right? And I know what they're asking. They're asking to find these three things, right? What's the area of the base?
30 inches squared.
Yeah, 1/2 times 12 times 5 is 30. Okay. Let's get the perimeter of the base. Yeah, so by the way, if it's that's a little nasty. That's not fun. So be it. Okay, so if I try to find the perimeter, what's x going to be here? It's not a clean number, unfortunately. It's gonna be a root, and so root 55, close. You're doing 25 plus 36. So x is it's root 61. So it's kind of nasty. So it's gonna be 12 and root 61 twice. So it's 12 plus 2 root 61. Yeah, I wish that was a nicer number. But does it make sense how I got that? Whereas the per the base. The base we figured out. The height, of course, is 25. And we don't have a cylinder, so don't worry about that. And let's calculate it. So lateral area is pH. Total area is pH plus 2b. And of course, volume is BH. Okay, so my perimeter is that's just very straightforward. You just do this. Technically, if you leave your answer like that, that's okay. I'm actually 100% comfortable with that. Or you do this. And that's square inches. Um, this one, I'm taking what I got earlier. And the base is, of course, 30. And volume is going to be 30 times 25, which is 750, I think, cubic inches. Yeah. Oh, because we solved it earlier, right? So basically what we're doing is we're being very methodical, right? We're calculating all the lower level stuff, which is pretty easy, and then using that to help us do the rest of the calculations. Because we established that a few minutes ago. So that's what I'm trying to do. So it's just good to really just break this down as much as you can and work out all the stuff, right? That's really what you're doing. You're just kind of sort of just plugging away. So questions on how to find the volume area of this prism. Looks like a tent or a triangle prism. We're good? All right. So now let's talk about scale factors. Now that we have this discussion. So we talk about scale factors, right? Linear scale factor is when you're comparing the sides or dimensions, right? So this is just simply comparing edges slash dimensions slash sides. So the per is going to be the same thing, right? 5/9 8/3. I'll worry about the other columns later. So perimeter follows the same thing. Now the area, you're going to do the linear scale factor raised to what power? Yep. And the volume, you're going to do linear scale factor raised to what power? Yep. So that's 25 over 81, or 125 over, use a calculator, over 729. So what's going to be true for the second column? If I complete the second column, what's the ratio to areas if the scale factor is 8 to 3? If you square 8 over 3, and if you cube it, a little hard to do 8 cubed in your head. They want to take a stab and try in their head. 512. Good. Okay. Do you do it in your head? Good. You want to explain how you did it? Because I can tell you're doing your head. I can tell. Yeah, if you do 6 times 8 is 48, and then but then it's really 480 because you're doing 60 times 8. And if you 8 times 4 is 32, add on the 480. 480 plus 32 is 512. Yeah, good. And 3 times 3 times 3 is 27. Okay, now we're going backwards, right? Now here's the strategy, and this is so, so important. This is going to drive you nuts if you do it this way. I'm going to show you a way to not drive you nuts, right? To undo that madness, right? Should I find this first? Or should I find that first? What do you think is going to be easier? To find the linear scale factor first for a third column, or the ratio of the volumes first? Do the linear scale factor first. Treat the linear scale factor as a bridge. That's going to just make your life so much easier. Because right now, to really focus on this, I'm confused. Like, how am I going to alter that to get the ratio of the volumes? Because what's happening, just so you know, area 1 over area 2. Don't write this down, by the way. This is actually, I don't want you writing this down, but if you were to work this out, if I'm not mistaken, I think it's raised to the well, I gotta think about this too because I'm confusing. I'm confusing myself. Um, I think you have to raise that to 2/3 power, which you've not learned how to do that. So anyway, let's not do that. It's just too complicated. So what I would do is let's find the linear scale factor. How am I going to alter this to get the linear scale factor? Square root. Yep. You square root it, you get 11/4. So that's an 11. Now, what do I do to get the ratio of the volumes? Yep. Now, that one I'm not going to attempt to do in my head. I know the bottom's 64. 1,313.31. Okay, cool. Do you do it in your head too? Okay. So yes, that seems to make sense. 13. Yeah, actually, if you do it in your head, you're doing 121 times 11, so it'd be 1210 plus add 121. Yeah, that's 1331. That makes sense. Oh, it's right there. Look at that. Okay. So here, so how am I going to get this now to get back to the linear scale factor? The cube root. You got to raise to the third power, which by the way, if you hit the math button, I think it's option 3 in your graphing calculator. If I'm not mistaken, I think. So that's 4 over 11. 4 over 11. That's 16 over 121.
Option 3 is to cube it, and option 4 is to cube.
Okay, so it's option 4. Got it. And option 5, I think you get to choose.
Cool.
Yeah. Okay. Yeah. So pretty straightforward, right? So knowing this, let's talk about some bullet point summaries. Use linear scale factor LSAF with linear dimensions, right? Area scale factor for area, like walls, floors, fields, wrapping, paint, etc. Volume scale factor for like capacity, right? Liquids, weight, melt shades, volume, things like that, right? So let's look at 3 and 4. I'll kind of tee it up for you guys for 3, and I want you guys to try 4 on your own or in your table groups. Very good. Sure, of course, yeah. So solid shape has a surface area of 196, a geometric similar, larger shape has a surface area of 484. Was the linear scale factor and was the volume scale factor? Okay. Actually, 196 over 484 equals LSF raised to the second power. I'll let you guys battle that. So tell me what LSF is in the volume ratio. So that's teed up. And go and try 4. All right, so go ahead and do the shot. Talk about it when we move on to new shapes. Yeah, and actually we have a little demonstration here. We have a water and cones and pyramids.
Thank you.
Whoever has steady hands, I'm gonna have them do a demonstration. In the last class, we'll spill water everywhere. I think I see it. Yeah, it's kind of a fun little demonstration here. So don't knock it over. What do you guys get for linear scale factor? 16 over what's that in 484? Is that 22? Someone can calculate that for me. Square root of 484.
$22.
22. Okay, cool. By the way, to make our lives easier, can we reduce that? Yep. LSF linear scale factor. Yep. It's up to you. Your call. Either way is fine. I think it might be a little easier. Actually, no, you get 64 over 121 if you simplify correctly. It did say 64 over 121. Oh, sorry. Oh, wait. You're right. Wait. It's not six. Wait, hold on. Wait. I'm wrong. Guys, I'm wrong. I made a mistake. See, this is why you don't do this in your head. That's 14. My apologies. So thank you, Faith, for catching me on that. I made a big error there. So 711. So my apologies. 7 or 11. So right, if you do reduce the fractions beforehand, you could totally do that. But you should have had 14 over 22 if you sorry, 49 over 121 if you reduce it correctly. And then you got to cube that. Hey man, go ahead. Of course. That's gonna be 343. I think. Is that right? Yeah, 343 over 1331. So that was hopefully pretty straightforward. Go and try 4 now. Don't overthink number 4. It's up to you. It's your call.
Ratio area surface area.
Weight's gonna be very similar to volume. Yeah. Yep. Because you're putting on the surface, you're not filling it up, right? So for number 4, find the LSF first. And note, weight ratio is like the volume ratio. So if you have 216 over 64, that equals the L sub raised to what power? To the second or third power. Yeah, that's why these problems are tricky. You have to recognize that weight is taking up space, right? It actually deals with, like, for example, if I pour more liquid in this, this is heavier, right? 100%. Or this right here. If this is empty, I can lift pretty easily. This is actually a little hard. I mean, I can lift it, but if I, one of those like challenges where you have to like hold. Anyway, that's going to be hard to do, right? My shoulder's going to fall off. You put more water in there. So volume deals with weight as well. If I cube root it, what's your linear scale factor? Hold on a sec. What's the score? It's 6. Oh, you did it the other way around. It's all good. It's all good. So you should get 6/4 or 3/2. Okay. Then we're doing the linear scale factor raised to the second power. And because we're doing small to big, because this is dealing with surface area, right? 6 pints. The paint. The paint because you're covering the entire surface. So if I do that up top here, 9/4 equals x/6. What's x going to equal? That will be, because you take it, when you're comparing the pints of paint that you put, that's the only surface area. And area, the ratio of area is always a square of the linear scale factor, as we established on the previous page. Whenever you're comparing area, you have to square the linear scale factor. Area. It's gonna be a square of the linear scale factor. Just as we established in the previous page. So it'll be 54/4, which I think is 13.5. And that will be how many pints of paint I need. So you see it's a process, right? We got to find the linear scale factor, then use it as a bridge, right? To bridge the volume and area ratios together, right? And by doing that correctly, if I square 3/2 which is 9/4, and cross multiply, you should get, the correct answer, 13.5. So, okay, good. All right, cool. All right, so now let's move to other stuff. Let's go back to the front of the notes. And just so we pace ourselves appropriately, you guys can get head start on homework. Actually, I do need to photocopy the homework too, but let's see here. So definitely want to talk about page 1 and probably page 2. If I can get to spheres, that'd be awesome. And then we can do the practice after that. Or the practice will be for the next day. All right. So pyramids. Okay, so let's talk about the anatomy of a pyramid, right? So apex. Apex is the peak. It's the high point. The height of the pyramid is going to be a segment that goes from the apex to the base. It's a perpendicular segment. So it looks like this. We actually call this the height of the pyramid. So like this right here, here's a pyramid. It's going to be, can I borrow your pencil? Yeah. So it's like that. So that right there, that's your height of the pyramid. So thanks. Sorry, there's water on it. Then the base is the bottom, right? That's the bottom face. Only one base, mind you, because the other opposite of it's just a point. The lateral faces are basically the triangles are slanted. That's going to be on the sides. So like all these different triangles is your lateral faces. The lateral edges is going to be the edge of the triangles, the sides of the triangles. That's the lateral edge. And this part's the trickiest part. The slant height, it's the height of the triangle. And of course, it's slanted because it's not perpendicular to the base, right? It's slanted. So, like, let me see your pencil one more time. So that's the slant height, like that. Just, that's slant height. Thanks. Um, so that's what's going on with pyramids. And properties of pyramids, usually we're going to make them regular, meaning all the sides of the bases are the same, and all the lateral edges are also the same, and all the triangles are the same. If it's irregular, that's going to be a little more complicated. I don't think we'll go down that path because that's just kind of cruel. So keep them regular. So if you were to take a regular pyramid and undo it, that's how it would look. You'd have your square base if it's a square pyramid, and the triangles be splayed out like that. So the shapes of the sides of the pyramid, obviously they're what shape are yeah, they're triangles. How do you find the area of each lateral side? Um, 1/2 times base times height. Or to be more proper, I'll call the side X, the side of square base, and L will be the slant height. So I'm calling this X. That's a little bit crappy drawing. Okay, still not great, but I'll call it L. So sum up the side areas below. That's 4 times 1/2 times X times L, or 2XL. What term do areas all have in common? I'm not sure what's meant by that. Let me look at the notes. I'm a little confused by that question, what that question is asking. Um, oh, yeah. So if I think about it, they all have X in common. So you can think of like perimeter. Um, can also do where that's a perimeter of the square base. Because if you think about it, you can do a little switcheroo here. Put 1/2 on the outside and 4 on the inside. And that right there is your perimeter. So you can think of it like that. That could work. Before we move forward, any questions about that? So the way you can express in the bottom here is expressed as 1/2 PL, where P is the perimeter. So it's kind of similar to what we did with prisms. We did perimeter times height. It's a little similar, a little different. But remember, you have 4 triangles, right? So the total surface area is going to be your lateral area plus. Any calculators? No, never had them in here. No. So it'll be lateral plus base, or 1/2 PL And the base, of course, is just the base, whatever base you have. So that's the total area. Now this part we have a little bit of fun. Okay. So who wants to do this little demonstration of pouring water? I think you want to do that? Okay. So I'm gonna have you pour. So here's a question. So here we have a pentagonal. So actually, oh, these line up perfectly, right? So a pentagonal base and a pentagonal base here, these line up perfectly. How many of these do you think will go into this?
Three.
Okay, I hear four, I three, or two. Okay, let's find out. Four. Yes, that's okay. It's just water. You gotta fill all the way out.
Yeah. There's like a chip like
Okay, go. Okay. All right. I have a lot of practice pouring milk for my kids. Steady hands. All right. Yeah, so all the way to the brim. Okay, we're good. So far that's not half, right? And Zoe didn't quite go all the way, but yeah, just a little more, yeah. Okay, there we go. Okay, so it's now more than halfway, but so it thinks to be three or four. Try three, yeah, three. Yeah, you see. It's a very simple demonstration, right? Yeah, perfect. Good. Awesome. Good.
Okay.
Well, you really did that. Okay, there we go. Okay. Yeah, it's almost full. So yeah, it's three. So that's what's happening there. Let me pour this back. Yeah, so what's happening for pyramids, it's like a prism, but it's 1/3. So 1/3 or three times the pyramid is the prism. So essentially you could say the volume of the pyramid is 1/3 the volume of the prism. So in this case, you're going to say 1/3 times the base times the height. So you got to find the area of the base, be multiplied by 1/3. Yeah. So for a pyramid in summary, and we'll give you these formulas, because I know it's a lot to memorize. So in summary, the lateral area is this: 1/2 the perimeter times the slant height. The total area or surface area would be 1/2 PL plus the base. So we have one base. And this is 1/3 the base and the height. This is the height of the whole pyramid, not of the sides or the faces.
No, L is not the actual height of the pyramid.
L is the height of the triangle, slant height. L is going to be this right here. Where this right here is H, right? From the middle of the base to that apex, that's H. This right here is L. Right. That's why we're spending some time trying to understand the anatomy of this. Cones. So yeah, this week it would be kind of a fun thing to do on Thursday. Like if I brought ice cream and you scoop up the ice cream as a sphere and you put it in a cone, you try to smash it all, and it tries to find the volume. I think it'd be kind of a fun. I don't know. I gotta think this through. How I'm gonna. That'd be fun. It's Thursday afternoon. Who does not eat ice cream? I don't know. Yeah, exactly. Yeah, exactly. Yeah. No, yeah, I'm with you. Yeah. Well, I do have a scoop. So we could just you can make the batter. That's a volume. You got to put it in like some sort of container. And I actually have an ice cream scoop where you get spheres, and you put it down and you bake it, and then you figure out how many cookies you could. I know. Let me think this. Let me think this through. Ice cream sandwiches. That'd be a great idea. So we get vanilla ice cream, chocolate chip cookies, or you want to think of the flavors? We could do different cookies, different flavors of ice cream. You mentioned chocolate chip and like snickerdoodle, I cookies, yeah.
Always lactose intolerant.
You are, she is? No, we could do, okay, anyway, let me think this through. This is, I'm getting excited for it. All right, cones. All right, so. Yeah, let's try another volunteer. So you want to try?
No.
Okay, so I'm against someone else wants a 4. Okay, here, let's go with 4. All right. Okay, so now here's a cone with a cylinder. The circulars bases match up, right? So you probably expect how many of these cones are going to go into 4. Yeah, good talk, Shira. Well, I'm going to scroll down space.
Three or four.
You're having, wow, you okay, you're okay. Slowly, slowly.
Find out the volume of the water on the floor.
Thanks.
Funny.
So it's 3. So so what's happening?
It's 3.5.
No, that's okay. And actually, if you don't thank you, Kira. Actually, if you don't mind, if you go to the bathroom,
Karen,
you see
gotta
the,
get some towels.
you know, if you get the yellow, no, get the yellow thing. It has like better towels. No. Just get the yellow caution thing. It has like really absorbent towels, so it's all good. So anyhow, if you were to, buy ice cream from like Baskin Robbins or anything like that, right, or wherever you like to go for ice cream, you get a container, right? But of course, the cone doesn't have as much, right? But I know they figured out Baskin Robbins or wherever you go to get ice cream. Exactly, but yeah, but then you stack it on top, right, to make it.
Yeah.
I always like the container. I think it's a better deal.
Let's get the cone on top of the container.
And my kids make a mess, so I prefer to get containers because cones are just really messy. So anyhow, as you can tell, so the lateral area, it's gonna be the same pretty much thing, right? It's 1/2, but the perimeter is not a perimeter necessarily; it's a circumference, right? Perfect. That's exactly it. Or,
Double.
but trust me, I've had a lot of experience doing that. Here, I got it. Yeah, it just and actually just leave it there. Then there you go. Perfect. Yeah, just leave it. Let it rest. That's perfect. That's
There.
so I don't slip any. Yeah, because then if I hurt my back, that'd be a problem. Then I'm gonna sue the school. No, actually, I get early retirement, so he actually would help me out. No, I don't. No.
So yeah.
Thank you. How old do you guys think I am? You guys want a guessing game? 48. Yeah. 48. Yeah. 48. Yeah. 77. I turned 49 later this year. Right. I don't know yet. I'll let my kids figure it out. I don't know.
My mom's 50. She was like absolutely no kids. She's like her own thing.
What was it?
Like my mom had her 50th birthday. She was like did not. She was like absolutely no kids.
Oh yeah.
That's cute.
No. Just saying that I let my kids figure out what to do for my birthday. That's what I'm saying. Yeah, that's what I'll let them figure. Yeah, my 50th birthday won't be for another year and a half. But November 13th.
But
Yeah. But my son's birthday is November 7th. So all my kids' birthdays are right for my birthday. So my youngest is October 23rd, the middle is October 29th, the oldest is November 7th, and then November 13th. And my mother's also November 13th as well. And she's 80 right now. So yeah. Yeah, crazy, isn't it?
Your mom has the same birthday?
Yep, I was born on my mom's birthday. It was on a Sunday. Yeah.
wait,
Yep. Anyhow, so 1/2 CL. Now the circumference is 2 pi r, so you can clean it up a little bit, call it pi RL if you want. So when you see pi RL, this does seem kind of confusing. Like, where the heck does that come from? But it really comes from 1/2 CL. The C is the circumference, which is like perimeter. The total area is going to be the same thing. The lateral area plus the base, which of course is pi r squared. So you can think of it like this: pi RL plus pi r squared. And some people like to even factor out the pi r and call it that. So the formulas can get a little bit complex, but at its core, just lateral area plus base, right? And the lateral area was 1/2 CL, and we cleaned that up a little bit to make it pi RL. So you can do that if you want. And the cone, that's pretty easy. That's 1/2 BH, which is 1/3 pi R squared. Geez, come on. Times height. So you can leave like that. And don't know if we really have time to. We can say sphere. Well, let me just briefly talk about sphere. We have like a few minutes. Let me briefly talk about sphere. Okay, sphere has no sides, obviously. It's all circular. It's like a ball. So it has no lateral area. We don't really worry about that. The formula is right there, 4 pi r squared. And for volume, consider a set of clear hollow plastic geometry models, including a sphere, cone, cylinder. They each have the same radius and height. Let's draw examples of each really quickly. So when I draw a sphere, I kind of draw it like this, like a globe. That's R. And of course, that's a height. For a cylinder, we'll do something similar. Tend to draw it like this. So now you're getting a little bit of lesson how to draw these. That's R. And that's height. And then, of course, a cone. That's R again. And that's height. So if you think about it, for a cylinder, hold on. Let me think about this one. If the radius of the sphere is R, the height of the cylinder. Okay. So if you think about H equals 2R, right? For a sphere. Do you guys see that? Why that's true? Right, because the height from here to here. If that's the height of the sphere, is that just the diameter of the sphere? Right? Right, because you go from end to end, when that's just the diameter, and it's the diameter twice the radius. So for a sphere, height of the sphere is the same as twice the radius. So height's twice the radius. Because the height equals the diameter. It's true for a sphere. Now, yeah, let's actually, let's stop there because I don't want to rush this. We have about a minute left. I don't want to rush it. So we'll stop there. Homework. I'm gonna put it in Schoology later today. It'll be stuff from the electronic textbook, but we'll stop there. Yeah. Okay, I think we're all set.
Uh,